Hello, very good evening and very warm welcome in this beautiful series for GATE 2027. And I myself, Shivam Dixit, welcoming you all on behalf of Physics Wallah, GATE Wallah. So, in last class, we have discussed about the basic concepts where three concepts were there through which the question could be asked. The first one is properties are exact differential. The second one is properties of ideal gas and its mixture. The third one is principle of thermometry, and the next one is basically the work and heat. We have already discussed about the work and heat. So we have discussed about the displacement work. Now in this lecture today we are going to start our first law of thermodynamics, and today we will talk about the first law of thermodynamics for a closed system. So basically in this topic, if you look at, then four major things are there that you need to study, and it is a 5-star topic. 5-star topic means if you go and check any year, right, any year of GATE exam, every year you will find at least one question from the first law of thermodynamics, either directly or indirectly. You will get at least one question from first law of thermodynamics. So here you will get closed system reversible work, that is the W is equal to integration 1 to 2 PdV, that we have already discussed yesterday. That was also a part of first law of thermodynamics. Today we are going to talk about the first law of thermodynamics for closed system. Then tomorrow we'll discuss about the first law of thermodynamics for steady flow open system, and then we'll talk about for unsteady flow open system. So hello, very good evening. So my audio video everything is fine, just let me know once my audio video everything is fine. So today we are going to start the first law of thermodynamics for closed system, right, for closed system. Okay, let's start, right. So the first law of thermodynamics for closed system, first it was given by none other than Joule. So Joule sir actually did a lot of experiment, and there is one very famous experiment, that paddle wheel experiment, and on the basis of these experiment he gave the first law of thermodynamics for closed system undergoing a cycle, right. So basically he gave the first law of thermodynamics for cycle, correct. First law of thermodynamics for cycle. So if you look at for cycle, then what he conclude, basically on the basis of number of experiment, Joule sir said that the net heat transfer sigma q, net heat transfer is exactly equals to net work transfer for a cycle. So this equation is basically the first law of thermodynamics, first law of thermodynamics for closed system undergoing a cycle. First law of thermodynamics for closed system undergoing a cycle. Yes, very good. Yes, very good. Now you can write in the form of like cyclic summation of, because there is possibility that you need to calculate the value of net heat transfer in some of the processes, right. So the better way you can write cyclic summation of dq is equal to cyclic summation of dw, correct. So this is basically our first law of thermodynamics for closed system undergoing a cycle. So he have given this particular equation. Now we have first law of thermodynamics for closed system undergoing a cycle, but we don't have any first law for a process. So now with the help of this equation we will find out the first law of thermodynamics for process. For this, what we need to do, we have to consider one most simplest cycle, right. Now I am going to consider one most simplest cycle, 1A2B1. Now this 1A2B1 is basically any cycle, any thermodynamic cycle which contains two processes, right? Now here if you apply the first law of thermodynamics, because this is a cycle, if it is a cycle then we can apply this equation. So what you will get that dq 1A2 plus dq 2B1, this is basically net heat transfer. Net heat transfer means heat transfer in this process plus heat transfer in this process is exactly equals to work transfer in this process 1A2 plus work transfer in this particular process 2B1. Clear? Right? Now I am going to consider one more cycle here, right? Now I am going to consider one more cycle 1A2C1, right? 1A2C1. 1A2C1. So if I talk about 1A2C1, then the heat transfer in 1A2, like A process plus C process is equal to, like you can assume like this for this particular cycle, right? So now I can write here the dq 1A2 plus dq 2C1 is equal to dw 1A2 plus dw 2C1. Now if I minus this both the equation, then this is minus here, minus here, minus, and here minus. So this term is going to be cancelled out, and finally you will get dq 2B1 minus dq 2C1 is equal to dw 2B1 minus dw 2C1. Right? So now please try to understand. See, here one very important conclusion I would like to share, right? I would like to share one very important conclusion that, see, work transfer is a path function that you have seen in previous lecture, that work transfer is depend upon the area under the curve when projected on a volume axis in PV diagram, right? And that gives the closed system reversible work. And like if end points are same and process is going to be changed, then work transfer will also change because area will change. So work transfer is a path function. It simply means that this work and this work is going to be different because it is depend upon the process, right? So here process is B, here process is C. Here process is B, here process is C, means this value and this value will be different, means this value will never be equals to 0. If this value is not equals to 0, means this is also not equals to 0. So from here you will get dq2b1 is not equals to dq2c1. Clear? This point is clear, right? So dq2b1 is not equals to dq2c1. Clear at this point, right? Mean heat transfer is also a path function. The very important point is that heat transfer is also a path function. Now I am going to write this equation in one different way, right? I am going to write this particular equation like this. So dq2b1 minus dw2b1 is equal to dq2c1 minus dw2c1. Okay, so now here you can see that this is for B process, this is also for B process. So we can write here dq minus dw for 2b1 is equal to dq minus dw for 2c1. It means that the, like, if you look at this particular expression, if you look at this particular equation expression, then dq minus, see, dq is a path function, dw is also a path function, but here if you look at, then end points are same, my dear. Here 2, here also 2, here 1, here also 1. And if process is changed from B to C, if process is changed from B to C, but the quantity dq minus dw is not changing, so this quantity dq minus dw is known as, is that property. This dq minus dw is known as property, and that is called as the energy of the system. correct? That is called as the energy of a system, right? So now I can write here dq minus dw is basically dE. dq minus dw is basically dE, correct? Means energy of the system, stored form of energy. Basically it is nothing but what? Stored form of energy. Now I would like to conclude whatever we discussed up to now, right? Whatever we discussed, sir, what should we do for theoretical part? Kamesh, for theoretical part, I will suggest you to go through either any book or something, right? Or you can use our notes, right? Our notes are available in our Telegram, and if you ask any of your friend, then that notes, paid batch notes, you can use. And like ESC PYQs, ESC prelims PYQs, you can solve where theoretical questions are there. So like that you can manage. Okay, let's talk about the next very important part. So if I conclude, like, actually we are studying what? First law. First law for what? First law for closed system, right? First law for closed system. If I'm talking about first law for closed system, here two things will be there. Either it will be cycle or it will be process. Either it will be cycle or it will be process. Either it will be cycle or it will be process. Now for cycle, we know the equation, that is sigma q is equal to sigma w. No problem at all, right? We can solve problem on this also, there is no issue, right? Now if I talk about the process, then it will come dq is equal to dE plus dW. dq minus dW is dE. dq minus dW is dE. Sir, I'm very much confused. I have PWSC paid batch, but I want to prepare for SSCJ. I told you that you will get no. I think if you are preparing for ESC, then J exam will also be covered. Don't worry about it. Okay. PK-NAG will be the better, like, good book, right? As far as gate exam is concerned, PK-NAG is enough. If you have enough time, if you have even more than enough time, then you can go for Cengel book. Cengel is little bit vast, right? Whereas PK-NAG is crisp, right? So I would recommend you the PK-NAG. So dq is equal to dE plus d. Now what is this dE? This dE is basically change in kinetic energy, right, plus change in potential energy plus change in internal energy du, right? Now if I neglect this change in kinetic and potential energy, if I neglect the change in kinetic energy and potential energy of the system, then I can write here dq is equal to du plus dw. This is the first law of thermodynamics for, this is the main equation, right? So this is the first law of thermodynamics for closed system undergoing a process. In better way you can write neglecting change in kinetic energy and potential energy of the system, right? Neglecting the change in kinetic energy and potential energy of the system. Is it okay? Is it okay? Okay. So finally, one more thing I would like to share here, one note point. See, there is one term defined as a enthalpy, right? Enthalpy. What is enthalpy? Right, macroscopically, if you talk about microscopically, I have explained to you earlier also that it is the total energy which is required for a survival of a substance, right? Which is actually, right? So here two terms are there basically, right? So enthalpy is H is equal to U plus PV, where U is the internal energy and PV is a flow work, right? So it is the like for open systems, if you talk about, then it is the total energy which is either entering or leaving from the control volume, right? Leaving from the control volume other than kinetic and potential energy of the fluid, right? So that is basically enthalpy. Now here one very important note point I would like to share, that for ideal gas, du is equal to what? Du is equal to mcv dt. dH is equal to what? dH is equal to mcp dt always, and U is the function of temperature only. This is for all the processes, right? All the processes, whether it's a reversible process or irreversible process or constant pressure process, constant volume, adiabatic, isothermal, whatever process it may be, du is always mcv dt and dH is equal to mcp dt, and use the function of temperature only. Sir, cyclic and reversible process are same? No. Cycle is basically what? Cycle is a combination of different processes, right? A cycle is a combination of different processes in such a way that the initial and final state of the system is same. And for a cycle, the change of any property is always zero. Why? Because initial point is same, final point is same, and properties depend upon the point only, right? State functions only. Now another point, if you look at, right, if you look at the another very important point which I would like to share here, that is what type of questions can be asked, right? From this one, very simple questions can be asked. Let me give you one example. Let's say we have PV diagram. Now I am going to draw here PV diagram, right? For air, here we have 1.1 to 2, then 2 to 3, then this is PV to the power gamma, sorry, PV to the power 1.4 is equal to constant. This is 1 meter cube, this is 4 meter cube, this is 100 kilopascal, this is okay. Yeah, is it enough information or some more information is required? P2. Q1 to 2 value is given as a 100 kilojoule. Find Q3 to 1. Find Q3 to 1, right? Can you solve this problem? Sir, I am very much okay. Right, can anyone solve this problem? Just now I have framed this question, so there might be some data error, even it will not be there, don't worry, you just solve it. So you have 2-minute time. You have 2-minute time. Please try to solve this by your own. You have 2-minute time. Please try to solve this by your own. What is the answer? So see, it is a cycle. So for cycle, we already know, for cycle, sigma q is equal to sigma w, right? So now I can write q1 to 2 plus q2 to 3 plus q3 to 1 is equal to w1 to 2 plus w2 to 3 plus w3 to 1. Now everyone please start to understand, right? Everyone please start to understand. See, q2 to 3 value will be 0 because it is adiabatic process, right? It is an adiabatic process. As it is an adiabatic process, so this value is going to be 0, correct? Now w1 to 2 value will be 0 because constant volume work is 0. Okay, q1 to 2 is directly given. Q3 to 1 we have to find out. So first we need to calculate w3 to 1. First I will calculate w3 to 1. What is w3 to 1? P means 100 into 1 minus 4 means minus 300 kilojoule, correct? It is minus 300 kilojoule. Okay, now come to 2 to 3 process. Now come to 2 to 3 process. So here you will get a P2 V2 to the power 1.4 is equal to P3 V3 to the power 1.4. So P2 value is how much we need to calculate? P1 V2 value is 1. V2 value 1 to the power 1.4 is equal to P3 value is 100. V3 value is 4 to the power 1.4. So from here you will get P2 value. From here you will get P2 value. Okay. So now I can write 4 to the power 1.4 into 100. So this value will come 696.44 kilopascal. That is basically P2 value, right? That is basically P2 value. Is it fine? Is it fine? So P2 value is known to us, right? P2 value is known to us, and okay, now what is now? Okay, and now we have to calculate W2 to 3, right? So W2 to 3 value is P2 V2 minus P3 V3 divided by 1.4 minus 1, right? So P2 value is how much? P2 value is 696.44 into V2. V2 value is 1 minus P3. P3 value is 100 into V3 value is 4, right? Divided by 1.4 minus 1. So what is the final answer here? Yes, very good. This value will come 400 will be minus 1, so 296.44. No, 296.44 will come on top, right? 296.44 divided by 0.4. So this value will come 741.1 kilojoule. Okay, so this value is also known to us. Now just put the values, right? Now everything is known. So Q1 to 2 value is 100 kilojoule. Q1 to 2 is 100 kilojoule plus Q3 to 1. 3 to 1 we have to calculate is equal to W2 to 3. W2 to 3 is minus 300 plus 741.1. 741.1. So Q3 to 1 value will come how much? So minus 300 minus 100. So this value will come 341.1 kilojoule. So this is basically your correct answer. So this type of question you can expect. 900 something? How you are getting 941? Just check the calculation once. There may be chance I did the mistake, but less possibility that I did the mistake, right? There is a less possibility that I did the mistake. Ruchika, please check. Ruchika, please check your calculations. Okay, no problem. Okay, now I'm moving to the next problem. Okay, just look at this problem. The cycle is 1, 2, and 3. So this is the cycle given here. So here volume is V by 2 and here volume is V, right? Now what the here pressure is P, volume is 2P, right? So now it is we start to solve. Okay. 1, 2, 3 is the cycle. For a closed system containing ideal gas undergoes the cycle as shown in the figure below. The process 1 to 2. Which one of the which one of the following statement is true? Okay, which statement is basically true? For process 1 to 2 you need to tell. Actually, if you look at here, one very interesting fact I would like to share for 1 to 2 process. For 1 to 2 process, my dear student friends, if you calculate P1 V1, what is P1 V1? P1 V1 will come PV. And calculate P2 V2. P2 V2 is will come 2P into V by 2. Is 2 cancel out, again it is PV, right? So basically you are getting P1 V1 is equal to P2 V2, right? P1 V1 is equal to P2 V2 and P1 V1 can be written as MRT1. Here you can write here MRT1 is equal to MRT2. MR cancel out. So T1 is equal to means whatever temperature is at point 1, the same temperature at point 2 also. Now this is the hint I have given to you. Now I have given to you a hint. Now I have given to you a hint. Now I hope you will able to solve this problem. T1, T2 is going to be same. Please try to solve this problem, everyone. This is a straight line. क्या IIT उन्हें एक्सेप्ट करेगी, किन्हें एक्सेप्ट करेगी? Okay. Now, if I apply the first law of thermodynamics, first law for 1 to 2 process, so I can say Q1 or dQ1 to 2, dQ1 to 2 is equal to du1 to 2 plus dw1 to 2. Correct? Right. Now, this we need to find out. Du value will come how much? mCv T2 minus T1. For ideal gas, mCv T2 minus T1. Just now I have told you. dW value will plus area under 1 to 2 in PV diagram. Right? Area under 1. So I have told you that the work transfer, see, this work is going to be negative first of all, because it is a compression process, right? Compression, and this area will give you the magnitude, right? This area will means minus of area, like this. Okay, I'll consider here negative, don't worry, right? So please try to understand that this term is going to be 0 because T2 is equal to T1. Now area under the curve 1 to 2, right? What is the area? And that area you have to take at a minus, right? Why minus? Why minus? Because compression work is there. Compression work is there, right? So I can write it Q1 to 2 is equal to, right? Now what is this area? This is a trapezium. Trapezium area is half sum of the parallel sides P plus 2P, right? P plus 2P, sum of the parallel side into this value, that is V by 2, into V by 2. So you will get how much? Minus 3 PV by 4. Right. Now minus is representing heat rejection. Minus representing heat rejection. So Q1 to 2 value will come 3 by 4 PV heat rejected. Heat rejected. Clear? So option B is going to be correct. Option B is going to be correct. Okay, solve this particular problem. I am giving you 2-minute time. I am giving you 2-minute time. Please try to solve this problem. Please solve this. Now here it is given that consider a piston cylinder device which is initially contains helium gas at 150 kilopascal, right? So pressure is given initially, and you please remember it is a helium gas, not air, at 20 degrees centigrade and 0.5 meter cube. So mass you can calculate. If the helium is compressed in a polytropic process, okay, PV to the power n to the 400 kilopascal and 140 degrees centigrade, the heat loss during the process, right, that too also in kilojoule you need to calculate. Okay, so final volume, okay, also we need to calculate. Okay, so first we'll apply P1 V1 is equal to MR T1. P1 V1 is equal to MR T1. So what is P1 value? P1 value is 150. Volume value is 0.5. R value of helium is 2.08. Into T1 value is 273, 283, 293 Kelvin. So now you will get M value from here, right? Right now you will get M value from here. Calculate the M value from here. M value from here. So M value will come 150 into 0.5 divided by 2.08 divided by 293, right? So this value will come 0.123 kg. 0.123 kg. Now what you need to do, apply another equation, that is P2 V2 is equal to MRT2. P2 V2 is equal to MR. P2 value is how much? 400 into V2. V2 value is how much? That we need to calculate 0.123 into 2.08 into T2. T2 value 140 plus 273, 413. So V2 value is this value will come 0.264154.8 meter cube. Right, now you have to calculate N value. Why we use ideal gas equation? Not ideal gas equation, because this PV to the power n is equal to constant is basically ideal gas equation for polytropic process. See, whatever n value you will get, my dear student friends, get to, right, whatever n value you will get, that is with regards to ideal gas, correct na? Right. Okay, now I am going to write here that P1 V1 to the power n. See, PV to the power n is equal to constant is the ideal gas equation for polytropic process. Actually, that itself is ideal gas equation. So P1 V1 to the power n is equal to P2 V2 to the power n, and helium is mentioned here. Yeah, helium is the ideal gas only. Helium, argon, CO2, air, nitrogen, oxygen, all these gases are treated as ideal gas. All these gases are treated as ideal gas. Okay. So now P1 value is how much? P1 value is 150. 150 into 0.5 to the power n is equal to P2 value is 400. 400 into 0.264154.8 to the power n. So now calculate n value from here. Okay, 0.5 divided by so n is equal to 4. So from here you will get approximately 1.8928 to the power n is equal to 4. This equation will take log, right? So n log this one is equal to log this, right? So ln of this value, when ln of 4 this value, n value is coming how much? Is n value is 2.1726? Just check once because I'm very bad in calculation with this 𝐂𝐤𝐴. Right, I'm very bad in calculation in this 𝐂𝐤𝐴 because see if I take ln here, then n ln. Oh no, wait, sorry. This value will not go 4. This value will come 400 divided by 150, right? So this value will come 2.6666. So ln this one. So ln 2.666. N value will come 1.5371, something like check. So 1.537, yes, correct. Very good, Kittu. 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 So now n value you have calculated. Now you have calculated n value, right? Now you have calculated n value. Now what you need to do? Now you need to calculate W1 to 2. W polytropic process, that is P1 V1 minus P2 V2 divided by n minus 1, right? So P1 value is how much, beta? P1 value is 150. So 150 into 0.5 minus P2 value is 400. 400 into 0.26415. 0.26415. 0.26415 divided by 1.537. 1.537 minus 1. So what is W value? Just calculate W value from here. So 150 into minus 402. So this value will come minus 57.1 kilojoule. Right, this is value W1 to 2. But actually we have to find out heat transfer. So we know, right, dQ1 to 2 is equal to du1 to 2 plus dW1 to 2. So du1 to 2 value will come mCv T2 minus T1, right? Yeah, mCv T2 minus T1 minus 57.1. Right, m value was how much? M value of 0.123. So 0.123. What is CV value of helium? CV value of helium, right? So CV value of helium value is R bar by M into gamma minus 1. So this value will come 8.314 divided by 4 divided by 0.67, right? This value will come 3.102 kilojoule per kg Kelvin. So this value will come 3.102. T2 value is how much? 413. 413 minus 293. Is it minus 11.32? Huh? Heat loss they are asking, right? Oh, sorry. I have taken here 2.08 and here I have taken 3. Where is the mistake? Four one three. Option is there by 11.2. Oh, sorry. So it is approximately 11.2. Option is there. Heat rejected. I thought option is not matching. D is the correct answer. D is the CV given है भाई. To CV you are already given, right? So no need to worry. You use this particular CV. In first class K2 I have gave you a formula. CV is equal to R bar by M into gamma minus 1, right? So D is the correct answer here. D is the correct answer. Where Q is positive, then heat is added, right? Yes. If Q is added to the system, see convention I can tell you here. The standard convention, listen here, standard convention. Suppose this is a system, my dear student friends, right? Now heat is added and work by the system. This is taken as positive. Means work by the system and heat supplied to the system is taken as positive. Whereas if it is a system and here work is supplied, work is supplied and heat is rejected, then it is considered as negative. So this is a standard convention that you need to follow. Arey Bittu Kumar, how are you? Bittu, your friend Kittu is also there. Bittu Kumar is a very talented guy, and Kittu is also there. Okay, now look this problem and try to solve this. Everyone try to solve this problem. Hello, very good evening. Everyone solve this problem. You have a 2-minute time. 2-minute time. Please try to solve this problem. The contents of a well insulated tank is heated by a resistance of 23 ohm. Let me draw the diagram for you. So it is a well insulated container type of thing, right? And it is going to be heated. Here W electrical is entering, right? W electrical is entering, right? And 23 ohm. This is 23 ohm and current is flowing 10 ampere. Current is flowing. Consider the tank along with all its constituents as a thermodynamic system. The work done by the system and the heat transfer of the system is work done by the system. Same convention which we are following. The rate of heat transfer QW and change in internal DU. All these things you need to find out. Very good, Bittu. So now I'll consider this as a system, right? This complete as a system you have to consider, right? Now W electrical is entering to the system. So it will come minus W work is entering to the system. So minus I square R. Rate, I square R. So I square R means minus 10 square into 23. So it will come 2.3 minus 2.3 into 10 to the power 3 joule, or we can say minus 2.3 kilojoule. Correct. So this is W electrical. Now there is no any heat transfer because Q value will be 0 because adiabatic, right? Now we will apply first law. First law, what is first law? Sigma Q is equal to sigma W. Sigma Q is equal to sigma W, right? We can assume that this temperature is same, right? The temperature or resistance is same, Kamesh. Temperature or resistance is same, but it is deviating heat, right? It is going heat at the same temperature inside the room, right? Inside the container. So, sorry. dq is equal to du plus dw. Now dq value is 0, du minus 2.3. So du value will come 2.3 kilojoule. 2.3 kilojoule. So what is the correct answer? The heat value is 0, okay. W value, yes, A is going to be your correct answer. So whoever have given A option, that is correct. A option, whoever have given the A option, that is correct. Okay, try to solve this problem. A thin insulated membrane separated two tanks initially filled. Nitrogen is there, carbon dioxide is there. The membrane arrival gas is allowed to form a homogeneous equilibrium. During the process there is no heat transfer or interaction between the constraints surrounding the final temperature. You need to find out. Final temperature you need to find out. Please try to solve this. CV value is given in joule per mole Kelvin, right? So N value will come here also, joule per mole Kelvin. Don't forget this. Oh, Bittu is saying that this problem, yeah, this is a PYQ problem. Yes, correct, Bittu. Bittu, you are studying thermodynamics, huh? Very good, Bittu. Bittu is a good boy. And your friend Kittu is also there. Bittu, Kittu. Bittu versus Kittu. Uh-huh. Very good. Bittu, solve this problem also. Bittu versus Kittu. Oh, Bittu versus Kittu. Bittu is a good boy. Also good boy. Kittu. Kittu is a good name, yaar. Kittu is a very good name. Okay. So here I'll apply first law of thermodynamics, right? First law. What is first law? dq is equal to du plus dw, right? So dq value will be 0, no heat transfer, no work transfer. I can say that du net is 0, means du of nitrogen, du of nitrogen plus du of nitrogen plus du of CO2 value is going to equals to 0. Now du of nitrogen is N of nitrogen. Why N I am taking? Because it is given per kilomole. CV is already given per kilomole. CV of nitrogen T final minus T1 plus N of CO2, CV of CO2 T final minus T2 is equal to 0. So what is N of N2, beta? N of N2 is 0.8. So this value is 0.8. CV value of N2, CV value of N2 is 21.6. 21.6 into T final minus T1. Answer is given in which unit? Kelvin only, right? So it is given 350. 350 plus N of CO2 is how much? 0.2. So 0.2 into CV of CO2 is 11.6. 11.6 into T final minus 300. Calculate T final from here. बहुत दिन से आपका सॉन्ग मिस किया है. कौन सा सॉन्ग? Which song? Tell me. Bittu beta, where are you? Kittu beta, where are you? Here I am, how do you do? So 0.8 into 21.6. So this value will come 17.28 times of T final minus 6048 plus 2.32 19.60 final is equal to 344.08 Kelvin or 344 I can say. So the correct answer is 344.1. Okay. 344.1. A is the correct answer. दिल दे दिया है जान तुम्हें देंगे दगा नहीं करेंगे सनम. अरे मेरा आवाज बहुत खराब रहता भाई. दिल दे. This song is there in Telugu also. दिल दे दिया है. दिल दे दिया है जान. Solve it fast. दगा नहीं करेंगे. Okay. Right. Very good. Now this is a homework problem. Today only one homework problem, right? Today only one homework problem, okay? Now if anyone have any confusion, anything, right? If anyone have any confusion, anything, you can connect me in this particular Telegram channel. So I request you to everyone to join this Telegram channel, Shivam Sir Physics Wallah. Join this Telegram channel, Shivam Sir Physics Wallah. And if you have any kind of confusion here, you can just let me know, okay? You can just let me know, okay? So this is all about today's class. So let's meet tomorrow, and tomorrow we'll discuss the first law of thermodynamics for open system, study flow as well as unstudy flow. Thank you. Bye bye.